But the part that bothers me the most is that by every indicator that I see, we are not effective in the overall education and learning of our youth. And we are paying a tremendous amount of money for it.
Here's a seed.
Okay.
Okay? Now hold on to that for a second.
Okay.
Imagine that I planted that in the ground.
Okay.
And a tree grew. All right? And here is a piece of that tree.
Sure.
Okay. Now, where did all that stuff come from?
So where do plants come from? You look at these beautiful big redwood trees, these great spreading valley oaks, and you know they start from this little tiny seed. It's miraculous. Where does all that weight come from?
Oh, the mass came from a lot of things, I'd guess. I'd guess from water that it sucked up from the ground. I would guess from minerals that it sucked up from the ground.
Water, light, soil.
Well, I suppose in terms of raw mass, most of it's probably derived from actual matter in the soil itself.
And some of it comes from water, obviously, but a large amount of it comes from the nutrients that the roots absorb from the soil.
Now, what would you say to someone who said to you that most of the weight of the tree came from the carbon dioxide in the air?
I would say I would have no idea. I'd have to think about that.
I would disagree because this same volume of air wouldn't weigh this much unless it was highly compressed.
I would say that's very disturbing and wonder how that could happen.
It's a very strange idea that somehow the air, which they view as nothing, as weightless, as insubstantial, somehow makes a tree, a giant tree that weighs several tons. I mean, that's absolutely incredible.
That'd be hard to believe because carbon dioxide is, well, it's a gas, and it doesn't seem intuitive that you could add mass taking in a gas.
But that's where it comes from. It takes those carbon molecules and packs them together via chemical reactions so tight that you get this huge mass. So what does it mean that these Harvard graduates don't understand the fundamental idea of photosynthesis?
How do we know a kid really understands something in science? Well, we try to teach them something, and then we construct our tests so that they do well. So if you have a very difficult idea that may take 2 or 3 years to learn, and you cover it in 2 weeks, you want the kids to do well on the test, so you have to test things that are trivial.
All young children know how to learn to construct meaning. That's the way they acquire the language, without any special coaching. But when they get in school, they start learning to memorize, learning to pass tests, rather than learning for understanding. Then the problem begins, and it continues right through university.
One of the things we're starting to discover is that many students can give the right answer, but when you ask them why, the way they got to the right answer is more often than not wrong.
I don't like asking why questions on tests. I spend so much time covering a concept. Then I ask the question why, and I get back so many different answers. It's sometimes very depressing to see some of the answers that you get back when you ask why questions. They're valuable, but as a teacher, it's sometimes very frustrating to see some of the reasons students think a certain scientific phenomenon takes place.
It's a very shallow, unproductive kind of learning. And that's what our brightest students do best, because that's where the payoff is. But at the end of this 20-year process, what do they have to show for it? Very little knowledge.
We did a study where we followed children from grade 1 right through high school. And we found that when we helped them understand certain basic science concepts in grades 1 and 2, this influenced their learning all the way through high school as compared with students that didn't have that instruction.
Well, there are fundamental ideas that have a big payoff for students.
2 years have passed since we last saw John Federico.
This is my chemistry book.
We just wanted to.
We asked John to reflect on our videotape of his younger self.
Thoughts about it?
I don't know. I don't know what I was thinking. I remember him teaching it, and I know he was a good teacher, and I know he didn't do anything wrong. And I don't think anyone was at fault. I think what the problem was that I think I didn't have a good, firm stand on the basics.
The most important thing for a teacher to know is what their students are thinking, what they come to class with. Unless you know what people's prior ideas are, you have very little chance of ever changing them.